Hey, welcome everybody. Video number 28A. That's right, A. Meaning I probably should have made this last week, but here it is now. And the reason I'm making this video is because last week we talked about supervised classification, and I wanted to quickly show you how to do unsupervised classification in ENVI. So in this video, I'll talk a little bit about what unsupervised classification is. Then I'll show you the two algorithms that ENVI has available, the kmeans and the ISO data. So recall that in supervised classification, there was 3 stages. We had to define the training groups first. Remember that usually involves drawing polygons on your image to extract spectral information from each of your end member user classes. So you're basically telling the computer, hey, I want these pixels to represent urban, I want these pixels to represent sand, corn, hay, and so on. And so if these different groups have different spectral characteristics, then we can run an algorithm that's going to actually separate these different groups from each other. So we talked about, for example, the minimum distance algorithm. We talked about spectral angle mapping. And all of these are ways such that if we actually bring in an unknown pixel, like this dot, we can actually find a way to group it to the training group that it is closest to, and therefore classify it. So this pixel obviously would be an urban pixel. And then of course the final stage is to output the results. So supervised classification works really well when you already know what we would call the user classes. You already know what the classes are that you'd like your final classified image to have in it. Unsupervised classification is quite different. In unsupervised classification, there is no training stage. In other words, you never tell the computer what user classes you'd like to have, and you don't give it any information about those classes. Instead, you simply start an algorithm and let the computer determine which spectral classes are most unique from one another. So it's going to go through, and based on the distributed data for all the pixels, it's going to group the pixels into whatever classes are most spectrally unique, and these might or might not represent meaningful things in your image. So after you've run an unsupervised algorithm, the next step is actually that you, the user, would have to determine what these classes are that the computer has generated. And usually we'll call these spectral classes. And then the user would have to go through and assign each spectral class into some user class. Okay, so let's look at our first unsupervised algorithm. This is going to be called the kmeans algorithm. And the way this works is that the user first specifies how many classes they'd like to have. And the computer goes through and randomly or not randomly picks a bunch of spectral center points for whatever number of classes the user has defined. It then goes through and it classifies the image by minimum distance. So this pixel is closest to red, so it'd be assigned to red. These pixels are closest to green, so they'd be assigned to green. And we end up with a classified image where the pixels have been classified into red, green, and blue classes here. Now the algorithm then repeats the step. It takes all the pixels in this green group and it defines a new mean. So for example, the mean would shift from here to here. The red mean would shift from here down to this pixel, the only pixel in the group. Then it repeats the minimum distance classifier, and notice that now this pixel is closer to the red mean, so it's grouped as red, and that's really the only change. So the algorithm will repeat this classification and regrouping until there is very little change, set and a change threshold set by the user, and then those will be your final classes. So the important thing here is that the user specifies the number of classes you'd like to have in the final image. The next algorithm is similar. It's called the ISO data. And in this case, the user doesn't specify an exact number of classes. Instead, you might specify a range of classes. And again, the computer will go through, pick some initial center points for the classes, and then it will do probably a minimum distance classification. But in this case, instead of grouping all the pixels into a predefined number of classes, the ISO data algorithm will actually create only as many classes as are justified by the data. And the way it does that is that if two classes have center points that are too close together, it will merge them after each iterative cycle. Likewise, if a class is too spread out, if its standard deviation is too high, it will split that class into two new groups before the next iteration. So this is a little different because it doesn't have a predefined number of classes. Instead, it just keeps lumping and splitting the data until it comes out with some number of classes that satisfy a predetermined standard deviation or minimum distance between means that the user can define. So the user is not defining the number of classes, it's defining the minimum distance between means or the maximum standard deviation within a group. Okay, so now you know a little bit about these unsupervised classification algorithms. Let's go ahead and look at how to do these in ENVI. Okay, so I've got my Yellowstone project brought up here. This is a true color image of a Landsat scene after the Yellowstone wildfires. So we've got some burned areas in black, got some unburned areas in green here. So you can find unsupervised classification tools, of course, under the toolbar, under classification, and then under unsupervised classification down here at the bottom. So why don't we start out with kmeans classification. I'm going to do this on my Landsat stacked image. I've got 7 bands. I'll hit OK. So here I can choose the number of classes, and I'm actually going to leave it set at 5 because I want to do bare rock, water, trees, unburned trees, and meadows. So that's great. This change threshold, this is if it changes by more than 7%, then it will do another iteration. If it changes by less than 5%, it will not do another iteration. I'm going to leave that set where it is. I'm going to let it do 100 iterations, and I'm going to set a maximum standard deviation from the mean. Let's call it 4 standard deviations. If it's past 4 standard deviations, then it's definitely not in the group. Okay, I gave it a file name, and I'll hit OK. So here come the iterations. It's on the first iteration now. So I'll pause for a second. Okay, so the kmeans image came up after 7 iterations, and we can see some interesting things. Notice it picked up this light blue group. If I look at that, that's actually bedrock here. But what's interesting is it looped this bedrock in with this, what I would have called a meadow, because there's some meadow grass on it. But to it, spectrally, this meadow looked more like bedrock. And you can actually see, if you zoom in, maybe see some bedrock sitting just under the meadow grass in there. So that's an example of where, to ENVI, that was one spectral class, this light blue and this light blue. But to a user, we might have called this a meadow and this bedrock. Great, so now let's have a look at the ISO data algorithm. So that's over here. Again, we'll do this on our stacked Landsat image. And so recall that for the ISO data, we don't actually put in an exact number of classes, but we can put in a range. So I'm going to put in a range of, why don't we go 5 to 10? We'll just leave it at the default. Going to let it do, again, 100 iterations. I'll leave the change threshold at 5%. I'm going to ask that it puts at least 500 pixels in a class. Maybe I'll make that 1,000. We have a lot of pixels in this image. Maximum class standard deviation, I'll leave that at 1. So that would be anything outside of 1 standard deviation would not be included in that class. And likewise, a minimum class distance of 5. So any class center points that are closer than 5 would be split into 2 new groups. And I'll leave this maximum number of merge pairs, well, I'll put that up to 3, so it could potentially merge as many as 3 groups at a time. Okay, I've got a file name ready to go, and I'm going to hit OK. So here it comes, iteration number 1. We'll take a brief break.
In 2013, when the Earth's rotation came to a halt,
declared all of North America a disaster area.
My fellow Americans to come together.
the world called on the one man who could make a difference. When it happened again, the world called on him once more, and no one saw it coming 3 more times. Now, the one man who made a difference 5 times before is about to make a difference again. Only this time, it's different.
Who left the fridge open?
Tug Speedman, Scorcher 6, Global Meltdown.
Here we go again.
Okay, we're back, and our ISO data classification has finished. Here it is. And notice that it did come up with a full 10 classes. So it came up with the maximum number of classes that we allowed. Probably would have come up with more if we'd allowed it to do so. And what that says is that there's a lot of spectral variability in this image. A lot of different surface types that can be spectrally unique. And just looking back at this bedrock patch and this meadow, notice now that these are really mostly in different groups. This is in a raspberry red color, which actually is what I would call meadow, okay? And down here, this green is mostly in bedrock, but now there's this new orange color as well. And this orange probably reflects, you know, bedrock with some small amount of vegetation on it. So one useful strategy at this point would be to go ahead and let ENVI create a large number of classes using ISO data, and then actually go through and combine classes to actually start lumping things into the groups that you want to use. So I'll just remind you, you can lump classes together, go under post classification and combine classes, and that will let you combine 2 spectral classes that you think should be in the same user class. To review, we learned what unsupervised classification is, and then we learned how to do the kmeans and ISO data classification in ENVI. Join us for our next video, number 29, adding a UTM grid in ArcMap. Thanks.